In today's lesson, we are going to be looking at equations with negative numbers. Now, we've already kind of looked at some of these examples before when dealing with the distance and time graphs, looking at a negative multiplier. So now we're just going to be looking at equations in general involving negative numbers, both in the multiplier and throughout, whether it's in a table of values or whether it's the y-intercept, whatever the case may be. So in our four examples here are four tables of values. We want to come up with the equation for this table of value, or for these tables of values, and fill in the missing pieces. So similar to what we've done before with the input and output kind of activities or examples in the past, we're going to be doing the same thing here. Looking at example 1, or A, again, we could, or you might automatically assume, well, this missing number has to be 4. We want to be careful of that only until we figure out what the rule is to verify that this y value would pair up with 4, because again, we don't know what the specific values are. We don't want to assume that it's going to follow the pattern of 1, 2, 3, 4, 5. There's a high chance that it does, but again, we just want to make sure that we're correct before we put that in there. So we really want to focus on points where we have both values. So what I mean by that is, if we look at these two examples here, or those 2 points, we have a full set, or an input and an output. So we want to use these two sets, or these two values, or points you could say, to figure out what is my multiplier, what am I increasing by every time. And if we look, we go from 7 to 17, that's an increase of 10. If I go from 1 to 3, that's an increase of 2. So I know, based on my pattern here, based on the table, for every increase of 2, I'm going to increase by 10. Or every time the x increases by 2, the y is going to increase by 10. Right? So you could say it's changing at a rate of 10 per 2, or 10 over 2. I want to figure out what is it going to change by every single time, every time x changes by 1. Because once I know that, then I know my multiplier. So in this case, if I change by 10 for every 2, that means I'm going to change by 5 for every 1. That means then, from 7 plus 5, that should give me 12. 12 plus 5 gives me 17. So that fits my pattern there. 17 plus 5 is 22. So that means that this number is in fact 4. And then 22 plus 5 is 27. So that's our last missing number there. That does give us some information for our equation. We know so far then, we know it's going to be y equals 5 is my multiplier, so 5x. Now I need to find my constant, or my starting value. There are multiple ways you could figure it out. Some of you may say, okay, 1 times 5 is 5. What do I add to that to get to 7? Well, in that case, I would have to add 2. You may do that and double check it with another one. 2 times 5 is 10. What do I add? It's 2. Well, that's the same thing. Okay, so that works. So that's going to be my constant. You may also work backwards. Right? We know if I take one step backwards and I get to 0, the y value is going to tell me my constant. So if I minus 5, in this case, my value is going to be 2. So that's another way we could figure it out, because we know when x is 0, the y value is our constant. For B, this one's a little bit easier because we have the values of sequential points, or the y values for sequential x values. So we increase by 1, y is actually in this case decreased by 4. So that's okay. We've dealt with negative multipliers before. This basically just means my pattern's decreasing. So in this case, y equals negative 4x. That's going to be our multiplier. So we can use that to figure out the rest of the pattern. So 16 minus 4 is 12. 12 minus 4 is 8. 8 minus 4 is 4. 4 minus 4 is 0. We now need to figure out what is our b value. So what are we adding here? Again, some of you may do 1 times -4 is -4. What do I add to get to 16? Well, in that case, it would have to be 20. And you can double check. 2 times -4 is -8. -8 plus 20 is positive 12. So that does work. That is our constant. If you're not too sure, not too comfortable doing that, again, work backwards. Go back to when x equals 0. Reverse our pattern. So instead of subtracting 4, we add 4. And we start at 20. So that means that our constant is 20. So again, different ways to figure it out. How you do it is up to you, whatever you feel most comfortable with. For C, again, same idea. Still missing the pieces. We're going to look at the points that we have the both values for. That would be these 2 points down here. So here, when I go from 3 to 1, I'm going down by -2. Or I'm going down 2. And my y value is going down 4. So that means that my y value is going to decrease 4 times for every time my x value decreases by 2. I want to figure out, well, what will happen when I decrease by 1? In this case, it would be if it's a decrease of 4 for every 2 that I decrease by, then it should be a decrease of 2 for every 1 that I decrease by. Or I could just say, if I'm decreasing 2 for every decrease of 1, then that means it's an increase of 2 for every increase of 1. So it's the same idea of saying my slope is 2. We now need to figure out our b value as well as fill in the rest of the points. Again, we can work backwards. So if we were to go backwards, increase by 1, then I would have to increase by 2. So that would make this 5. Go backwards, increase by 2 again. That brings me to 7. So that means this would increase by 1 and take me to 5. And we do see that we have the 2 and 1 in here. So we could use that or take this point and plug it in between and just basically rewrite our table to better see that value. And again, you could rearrange these points or values in the table if you wanted to, just to make it a little bit easier to see the pattern, as long as you keep them paired up correctly. So the 2 and the 1, the 5 and the 7, and so on. We do need to figure out what our b value or our constant is. Again, we can continue on with this pattern. If I go backwards, or if I continue, if I go down to 0, that means I need to decrease this by 2, which would take me to -3. So that means, just move this down a bit, that my equation is going to be y equals 2x minus 3. Again, you could have checked it out the other way. 1 times 2 is 2. What do I need to add to get to -1? Well, I need to take away 3. 3 times 2 is 6. What do I need to do to get to 3? I need to take away 3 from 6 to get to 3. So again, different ways you can figure it out. For D, again, same idea, right? We're given different sets of points. Here we're not given points that are sequential, so we might have to do a little bit of work, or the pattern or the multiplier may not jump out to us right away. But again, let's check. What do our y's increase by? Well, from -5 to -11, that is a decrease of 6. What do the x's change by? Well, from 1 to 3, that's an increase of 2. So that means that for every decrease of 6, my x's increase by 2. I want to know what happens when x increases by 1. Right? So basically, you find an equivalent fraction, or basically, if you're decreasing by 6 for every 2, half of that would be decreasing by 3 for every 1. In this case, then that means, jumping ahead, that means that we have a multiplier of -3. and we need to then figure out our constant. To fill out the rest of the table as well, we can continue that pattern. Because we're increasing by 2 here, that means we would increase by 6. Or sorry, decrease by 6. So negative 11 minus 6 is negative 17. If I go backwards, I can see that from 1 to 7, that's an increase of 6. So going the other way, I'm going to do the opposite, decrease by 2. So in this case, negative 3. Now I need to figure out what my missing value is or what my 0 value is. So that is going to be in between these 2 points. We could work backwards again, going backwards from 1, decrease by 1, going backwards from negative 5. For a change of 1, it's going to be minus 3, or adding 3. So in this case, we get to negative 2. So our constant is going to be negative 2. So that is going to be our equation. So again, it is a little bit trickier when we're dealing with negative numbers or when we're dealing with a table of values. It doesn't have sequential x values. But again, using what we know about the multiplier, we can figure that out. And then we just have to continue the pattern to help us figure out that b value or that constant. In example 2, now we're going to try to come up with an equation when we're given a graph. So there's a couple things we want to look for. The first thing that we should always look for when trying to come up with an equation for a graph is the b value. And the b value is going to be where the line touches this y-axis. So an easy way to do it is just draw a line straight down, or just look straight down. Where does my line touch? Well, in this case, it's at 0. So I know my equation is going to be y equals something x plus 0. Or in this case, I don't even need to add that 0 in. I'll leave it in there for now. To figure out the m value, I need to figure out some nice points. So we could say the first point 0, 0, the next point 2, 3, or sorry, 2, 300, 4, 600. And by nice points, I just basically mean where can I easily tell the value of the points that when they're on the line. So in this case, I'm going to just create a table just to organize my points. I have 0, 0, 2, 300, 4, 600. I need to find what my change the m value is, or the multiplier, every time I increase by 1. Because it's not easy to see the increase by 1, I'm going to have to focus on just an increase of 2. So for every increase of 2, the y value increases by 300 every time it increases by 2. So if it's 300, say dollars per 2 weeks, I want to know how much is it going to be every single week. In this case, 300 divided by 2, or half of 300, gives me 150. So that means my m value, or my slope, is going to be 150. It's going to increase by 150 every single week. So again, we could have our equation as y equals 150x plus 0, or just y equals 150x. For b, again, same idea. Go down your y-axis first till you see where your line starts. That's going to be your b value. So I know right off the bat my equation is going to be y equals something x plus 8, because I'm starting at 8. Now to figure out the multiplier, I need to figure out, or I need to find some nice points. And by nice points, I need to know where my line nicely or neatly crosses a grid or the grid lines so I can figure out the actual values. So in this case, X and Y, I'm going to start off with my first one. I'm going to say 0 and 8. Keep it color coded. 0 and 8. I have 1 and 6, 2 and 4, 3 and 2. Now you don't really need that many points. Really all you need are 2 points, especially since we already know what the B value is. In this case, because they're sequential, so 0, 1, so it's an increase of 1, I just need to figure out what do my Y values increase by or decrease by. In this case, they decrease by 2. And you could see by checking the other ones that that is the same throughout. So that means my slope is going to be -2. So again, same idea, kind of what we were doing before, except now we have a graph to look at. In the last example, we are given one representation of a linear relationship and we need to fill out the missing ones. Again, similar to what we've done already before. The only difference is now we're going to be dealing with some negative numbers. So our context, or the word part of our equation, we have the temperature one evening in January is -5 degrees Celsius at midnight. Every hour past midnight, the temperature decreases by 1 centimeter. So again, we talked about reading through and figuring out what's important. We really have two numbers, -5 and decreasing by 1. So we know that has to be involved in our equation somewhere. If we're not too sure, that's okay. We can start off with a table or a graph first. Again, if you're comfortable jumping right to the equation, that's fine as well. I'm going to start with a table, and I'm going to say for X hours past midnight, I'm going to say 0. So right at midnight, what's the temperature? 1 hour past midnight, 2 hours, 3 hours, and 4 hours. So that's going to be the X values for my table. The Y value is going to be based on the context. So it tells us that at midnight, or 0 hours past midnight, it is -5. It also then says for every hour past midnight, it decreases by 1 degree. So if it decreases or it gets colder, then it becomes -6, -7, -8, -9. So right from this, now we should be able to jump to an equation if we wanted to, right? Because we do have our B value, because we know when X is 0, the Y value is our B value, so we know we're going to have -5. And we can figure out our M value because we can see what does our X value or our Y value change by every time our X increases by 1. So in this case, our X increases by 1, our Y decreases by 1. And we got that from the word part or the context as well. You can see those two parts in there. The -5 is the starting, and decreasing by 1 or -1 is our slope or multiplier or rate of change. So that means my equation is going to be y equals -1 x minus 5. And then to graph that, I can just plot the points. So I know that when x is 0, y is -5, and then it just decreases by 1 every hour. And again, you could continue to plot the other points, or again draw a straight line to represent that. Oops. So there is our 4 representations for a linear relationship. We now have 2 questions that we are being asked based on that relationship. We want to know, what will the temperature be at 7 a.m.? And show your reasoning. So at 7 a.m., that is 7 hours past midnight. Or in other words, based on our context, that is our x value. So I want to know when x is 7, what is the y value? So I do have the nice equation, y equals negative 1x minus 5, and I can plug that value for x in and solve for y. So y equals negative 1 times 7 minus 5, y equals negative 7 minus 5, y equals negative 12. So that means therefore it is negative 12 degrees Celsius at 7 a.m. The second question is, if the temperature is negative 16 degrees Celsius, what time is it? Show your reasoning. So this value here is the y value. So you could plug the y value into your equation and solve, which would look something like this. Negative 16 equals negative 1x minus 5. So you may be able to go through and solve that equation for x. We haven't really talked about that too much though. But you could think of it as, again, like your input and output table. We know that the y value is negative 16. We don't know what the x is. We know that going in the one direction, to solve, we have to multiply by negative 1, and then we have to subtract 5. So if we go in the other direction, and we've talked about this before, we have to reverse or do the opposite. So we would add 5 and divide by negative 1. So in this case, if I took negative 16 and added 5, I would get negative 9. Sorry, not negative 9. Negative 11. If I take negative 11 and I divide it by negative 1, I'm going to get positive 11. So therefore, that means that my x value is going to equal 11. So therefore, it is 11 hours past midnight. 11 hours past midnight when it is negative 16 degrees Celsius. So again, different ways you can figure it out, and same with the first one, finding the temperature at 7. You may just extend the table to 7 a.m. or 7 hours past and figure it out from there. You don't have to just use the equation. However, the equation is a little bit easier depending on how far down the table you would have to go. So again, the main thing in this lesson is just understanding that the equations that we've dealt with before, in terms of coming up with y equals mx plus b, or the rule, we can now start to deal with negative numbers. So hopefully we can understand that the steps are still the same, even though we may be dealing with negative slopes or negative constants, or just negative values in general.